Hi, Electron John, the drivability guy here with you. We're continuing on with our educational series. Today we're going to be talking about fuel systems. So as you can see, we got plenty of fuel system related stuff out on the table for us. We also got a car behind us that we're going to attempt to do some live different types of testing through some of the comments that I've been reading from the channel here as of late, that you asked to see a little bit more hands-on. So I'm going to try to do as much hands-on, but we still have to have an understanding of what we're doing. So I'm not sure how long this video is going to be. We're going to give it a shot. We're going to see if you guys don't mind watching a longer video. You know, we'll start incorporating more and more hands-on stuff as we go through these continuing educational series here. So fuel systems. We all know that fuel systems have evolved over the years. We could go all the way back to carburation, which I've got one or two quick little slides. We're not going to spend pretty much any time on carburetors because if you're like me, you probably haven't seen a carburetor come into your shop in decades. So we'll start with the carburation. We'll kind of tell you why we got away from carburetors, and then we'll go right into fuel injection and how fuel injection has evolved over the years. So what were the big problems with carburetors? So the big problems with carburetors were they were mechanical by nature. So anything mechanical eventually is going to wear out over time, so we'd have sloppy linkages. It's also very temperamental for huge degrees of weather changes with the chokes on the vehicles and stuff. And if they had a manual choke, you know, a lot of times customers would pull the choke and step on the gas pedal to start the car like they're supposed to, but they'd forget to turn the choke all the way off, you know. So then you'd have fouled out spark plugs and everything along those lines. Mixture control devices, once we came out with computer controls, those weren't very sophisticated. So in essence, we're taking a metering rod out of a jet, and it's a tapered metering rod, so the more we pulled it out, the more fuel could go in. One of the biggest problems with fuel that we need to understand is fuel has to be atomized. So in order to atomize it, you know, with a carburetor, we would step on the gas pedal or whatever, the accelerator pump would just dump a bunch of fuel inside the combustion chamber. We needed to have heat to help the atomization process. Liquid fuel, as you guys are well aware, doesn't necessarily burn. It's the fumes that actually burn. So, you know, they weren't very efficient overall. And some of the problems that we talked about were, if you think about that actual intake manifold there, we would get a puddle of fuel, and if it was a V8 styled or 6-cylinder or whatever style design, wherever the fuel was at in the center of that intake manifold, well, those cylinders would technically run richer. Where the outside outlying type of cylinders, that fuel would have to get sucked into each one of those intake runners. So those would always be a little bit on the leaner side. So that was a balancing type of problem. Another big problem with those systems were a lot of times we would use a mechanical fuel pump. And a mechanical fuel pump like this obviously is being driven in some way, shape, or form off the camshaft, and it's a pretty strong diaphragm inside there with the spring on the mechanical arm over here. So there was a lot more load being placed on the engine by having to drive this fuel pump. Modern day cars, as you're well aware, use an electric fuel pump, so you know we don't really have that extra drag on the engine, which cleans up the emissions coming out of the tailpipe because they don't have to work as hard. So before we get into fuel injection, let's talk a little bit about fuel. And I'm going to just throw some random thoughts out there. You know, fuel is, you know, vitally important. We used to have leaded gasoline. Now it's all unleaded type of gasoline. There's different octanes of fuel, obviously. There's different alcohol content in fuel as well. Everything from the winter blend gasolines, which roughly has about 10%, all the way up to E85, the latest and greatest. So we're going to talk about fuel for a little bit here, and a couple little cases in point. If you ever pull up to a service station or a gas station, whatever you want to call it nowadays, and you happen to see one of those tanker trucks there filling up the underground tanks, probably not the best time for you to fill up your car. Now, obviously, if you need gas and there's no other fuel station in the vicinity, you know, anything goes at that point. But if you think about it, any type of contaminants that's in that tank in the ground, when we're dumping in, you know, hundreds, thousands of gallons of gas from a fuel tanker, it's stirring up that. So you'll have a tendency to want to, possibly get some of that debris inside your fuel filter and restrict your fuel filter. So it's better to not buy gas if possible when you see a fuel tanker truck there. The difference between leaded and unleaded gasoline, it's not a big concern of ours anymore, but when they stopped making leaded gasoline, there was a lot of cars out there that still ran on leaded gasoline. I have a classic 68 Camaro in the corner of my shop. That car was originally designed to run on leaded gasoline. So the extra lubricants that the leaded gasoline provided us, we had to all of a sudden change the internal design of the combustible engine there so that it could account for the fact that we no longer have those extra lubricants inside there. Octane levels, the higher the octane, the better the burn of inside that cylinder, the more power it's going to create. If you use nothing but premium gasoline, maybe you did a tune-up on a car in the past and you took the spark plugs out and you read the stories that the spark plugs tell you, and you notice that the ceramic material around the center electrode has like a reddish or a pinkish appearance. Well, that's coming from the higher octane fuel that they're using. So the problem is the alcohol. There's advantages to using alcohol in fuel. And those advantages are, number one, alcohol doesn't freeze as quickly as gasoline does. So for fuel line freeze up, which is why we put all across the nation during the winter months, we're allowed to have up to, roughly 10% of alcohol in the fuel here in the States. But once the summertime, springtime comes out, a lot of times we don't have that high of alcohol content anymore. It also will burn cleaner than gasoline. Now, why don't we want to have just alcohol inside there? Well, alcohol wreaks havoc on all your components in your fuel system. It's harder on your fuel pump itself. It's harder on any type of rubber type of lines that distribute the fuel from the back of the car to the front of the car. There's a lot of disadvantages to the alcohol too. The other thing too is alcohol burns at a faster rate. So anybody that has a flex-fueled vehicle, which basically means it can run on regular gasoline or it can run on E85 gasoline. E85 is cheaper when they fill up their tank, but it doesn't last as long because it burns faster than the regular or unleaded type of gasoline that we're accustomed to filling here. So with that being said, those are some of the advantages and disadvantages of the alcohol. Now, if you wanted to ever do any type of fuel system test on your car, here's a company, it's called RevX. They make this nice little thing, but you could pretty much use any type of clear container, put some lines on it yourself. And basically what you do is you fill it so much with water, and then you put the rest of it up to the top line with gasoline. And then you let it sit totally still. So it's moving around a little bit from me grabbing it off the other cart. But over time, you'll see how the water and the gasoline and the alcohol kind of separate from one another, and it floats on top of the water. So this gives you kind of an idea of how much alcohol is in the fuel content on your car. Plus, it's see-through, so if there was contaminants in the fuel, you'd actually see debris laying in the bottom of it as well. So where this becomes so important is, a lot of the E85 type of cars that we have on the road today, there's a sensor that's on the fuel rails that will always be able to determine how much alcohol content's in that tank of gas. If you think about it, let's say one time you fill it up with E85, but then afterwards you start putting, conventional unleaded gasoline in there. Well, you no longer have 85% alcohol. You have maybe, a mixture of that of some sort. It could be down to 40% or whatever, depending on when you filled your tank up last. Well, the car's computer always has to know what the alcohol content happens to be, because if it doesn't really know how to change the fuel delivery and spark timing curves. So that extra sensor is primarily just being used to determine how much alcohol content's in the fuel system that the fuel system happens to be using at that time. It's constantly being updated. There's a lot of cars out there, some of the older cars, that's in the late 90s, early 2000s, where those sensors would fail, and when they would fail, it could actually even cause a no start type of thing. So that's like a little silver bullet that I'll throw out there for you guys. So that's something to keep in mind. This car is not E85 behind us, so I can't show you that sensor with the scan tool or nothing, but I wanted to make reference to that before we went too much further. So you might be asking yourselves, well, what's the whole deal with the gasoline in the first place, right? If you ever had one of those old-fashioned lawnmower or any type of yard equipment, gas cans, you remember that it used to have a little vent on the back of it. And the federal government got involved, and to me, I hate the fact that they got rid of that vent because it's a lot harder to get the gas out of there at this point because there's no air vent helping you, spill the gas into the gas tank on your snowblower, lawnmower, whatever the case happens to be. But the reason why they did that is because gasoline in a sealed container has something that's called a Reid vapor pressure. And lots of things affect the Reid vapor pressure of gasoline. Alcohol has Reid vapor pressure values as well. But one of the things is it's a sealed container. Temperature plays a big part. That's why you may hear on a hot summer day on the radio, they tell you, hey, it's an ozone alert day. Don't fill up your gas tank. Because basically we need some place for those expanding hydrocarbons to go. So if the gas tank was totally full with liquid, there wouldn't be as much room for the extra fumes that's being created at that point. Also, with that being said, as far as the Reid vapor pressure goes, this helps explain why over the years, the car manufacturers, there was a time when we used to just vent it right out to the atmosphere. Now we use an evap system. And then we took it a step further and we did a returnless fuel system because also the flowing of that gasoline also has an effect on the Reid vapor pressure. So instead of taking the gas from the gas tank, sending it up to the engine more than what we needed, and then returning it back to the gas tank, what we did not need for that particular engine running cycle there, that extra sloshing of the fuel going back into the tank would have an effect on the Reid vapor pressure as well. So that's why, evap systems have evolved. In theory, simple forms, we'll eventually do a series on evap systems, but in simple forms, that's how an evap system is designed to work. It's supposed to take those expanding fumes, and instead of venting them to the atmosphere, it stores them in a canister, usually under the hood or under the car, depending on the vehicle you're working on. And then the next time you start the car up, your purge solenoid will just open up, and vacuum will suck those fumes out, and you'll burn them through the active combustion of the engine. And we don't necessarily have too many vehicles out there that still use a return line on the fuel systems. So that started back in the early 2000s. So continuing on with fuel, let's talk a little bit about fuel pumps. So we have all different types of fuel pumps that are out there. I showed you one already. That's the old-fashioned mechanical one. That's a relatively low pressure. Then we got into what we called high pressure, which were electric fuel pumps. Those could be found, mounted to a frame rail on a car. They could be found inside the gas tank, whatever the case happens to be. But we no longer really call those the high pressure fuel pumps because we came out with something called gasoline direct injection, which is really high pressure. So before we were dealing with, maybe 30 PSI up to say 60 PSI on average. Nowadays with gasoline direct injection, we'll still use that conventional style fuel pump, what we call conventional nowadays, but we call that the low pressure system where the true low pressure fuel pump was, somewhere between 3 and 7 PSI for many, many decades. So a high pressure fuel system, you will use the low pressure pump to actually pump it up to the fuel rail area, but it goes through the high pressure pump, which happens to be this guy here, and that could take the pressure and go to several hundred PSI, if not, over 1,000 PSI. And this will be driven right off a camshaft lobe. We'll be talking more about this as we go through the presentation here. So we also came out with something that's called three-phase fuel pumps. So I give Toyota credit for this. I could be wrong on that, but they were the first ones that I ever came across with it. Three-phase fuel pumps operate a little bit differently. A conventional fuel pump, we give it a power and a ground, it would actually start to pump fuel. However, a three-phase fuel pump operates much like your alternator or your motor generators in an electric drive type of vehicle, whatever the case happens to be, where we're pulse width modulating that signal. So in order to test those, you can't really just hook up your lab scope to it. You can't really just give it power or ground. So you need some type of three-phase tester. If you've been watching along with this series, you know that a good buddy of mine, Joe Casey, Joe's Auto Electric, actually makes a tester for that. that you can then hook up to the car and then hook your scope up to it, or your multimeter or whatever you're using to test it, and you could get valid test results from it. So the three-phase fuel pumps are relatively new. More and more car lines have gone that way. Like I said, I give Toyota credit for being the first ones, but don't quote me on that. That's just the first car line that I saw using the three-phase fuel pumps. Now, when we're talking fuel pumps, before I move on here, here's an automotive fuel pump that would be part of the actual sending unit inside the tank. I obviously removed the fuel pump from it, cut it apart so I can get the most important part of this out. And here's the little armature. And you'll notice that this armature's got a total of 8 different segments on it. So this is a brush style setup. So as this thing rotates, this is what's creating what's called a fuel pump current waveform, which has a lot of diagnostic information in it if you know how to acquire that waveform. So as we continue on with the fuel pump testing, any type of motor. So a fuel pump is nothing more than essentially some type of little electric motor here, a modern day fuel pump. So we got a couple ways that we could test it. We can overall test the fuel pressure, right? That's a test that we've all done a million times. We hook up a fuel pressure gauge to it. Some cars it's easier than others to actually hook up the fuel pressure gauge to it, and we're going to get an overall pressure. However, if there's any type of restriction in the system, that pressure is always going to want to read the same value, right? I used as in one of the previous videos, putting your finger over the water hose as an example, right? So you're restricting the actual flow of water, but the pressure actually increased there. So that's where using a fuel pressure gauge, kind of like this one, becomes a lot more valuable for us, because this type of fuel pressure gauge will not only read the pressure with the gauge up on top, but it also has a flow meter inside of it. Now, in order to use this tool, I got to hook up to the supply line, the pressure line, but I also have to have a return line hooked up, and I'm actually not only reading the pressure, but also reading the volume of fuel there. Now, if you don't happen to have one of these fancy tools out there, you can do the same thing with your conventional fuel pressure gauge by getting the actual pressure by reading off the gauge, but they always have some type of bleed on them, right? So you could take this other hose from a conventional fuel pressure gauge, and you can just time, so you push this button, the car's still running at the time, and you just go ahead and divert some of that fuel pressure into some type of clear bucket or a clear bottle of some sort, and then you're going to measure, after say 15 seconds or so, how much fuel is actually filled up inside that clear container there. And that gives you a pretty good idea of what the actual flow is. It doesn't give you the exact idea like this more fancy fuel pressure tester here is, but a lot of cars don't have a return system on them anymore, as we just stated, so it becomes a little bit harder to make the hookup with this tool as opposed to a conventional fuel pressure gauge, which is why you could revert back to what we used to use for years before a tool like this ever came out, where we just used a clear cylinder of some sort to get an idea of what the flow was. So a fuel pump, before we continue to go on, we don't send direct power and ground to it, right? Because that's going to draw higher amperage, and a car's computer is in control of allowing that fuel pump to turn on. So any computer on a car can't handle more than about a 3/4 of an amp draw. So we'll use a relay. So there's going to be a fuel pump relay. Maybe if it's a modern day car, it might be a fuel pump module, driver module, whatever the case happens to be. So we're going to be using something that's going to take low current coming from an actual PCM on a car, or ECM, whatever you want to call it, and be able to control a high amperage type of device, such as a fuel pump. Relays are used for that same purpose over and over again all throughout the car. Doesn't matter if it's cooling fan relays, whatever the case happens to be. So with that being said, it's important to be able to test that circuit on a car, which I'm going to show you how to do that here in a second. But if I use a low amp inductive current probe, I'll get a fuel pump waveform. Now there's a lot of advantage to the fuel pump current waveform. So number one, we will see that, hey, on the top picture being displayed on the screen, You'll notice that what we're after is, I call those camel humps. We would like to see uniform camel humps for a good fuel pump, right? We got a couple dropouts there. So when I look at that, I know I can just count how many camel humps are between there, and I know at that point how many commutators are on the fuel pump, right? So let's just say that there was 8. I would know that there's 8 because in between each one of those times of dropping out, there's 7 other ones, and then the dropout one. So if you've ever had any vehicle come into your shop for any type of motor, whether it be a fuel pump, whether it be a blower motor, a wiper motor, a cooling fan motor, a starter motor, at some point in our careers when we were relatively young and naive, maybe we had a no start where it didn't crank, and some old time, seasoned veteran told us, hey, go underneath the car while I hold the key in the crank position and hit that starter motor with the hammer. So basically what you did is you made a little bit of a vibration which allowed that commutator to have better contact with the brushes. So any type of brush style motor is subject to this type of failure. So there's a fuel pump waveform that I have from a previous case study that I did over the years, where the customer's complaint was they call you up and they say, hey, my car doesn't start. So the car cranks and everything, but there was no fuel pressure because the last time it was shut off at was on one of those dropout areas. By the time the car came to my shop, the car started up no problem, right? So again, I'm always under the firm belief that the customer is not lying to us. He's not just lonely. He doesn't want to come visit me and makes up some erroneous problem. So I got to take that type of complaint and I got to say, well, what could cause that from happening? One of them being the fuel pump, right? Another thing could be with the ignition systems, not really in this video. So I just went ahead and did a quick, simple hookup with my low amp inductive probe. When I saw that, I knew that it was a fuel pump that was causing the problem. The reason why it started when it came to my shop was because a tow truck jostled it around enough that we had better brush contact with those commutators there. Now, if I know that how many commutators there are on that fuel pump, I can also determine not only the overall amperage, which would be the height of that waveform, but the speed of that fuel pump. So here's a little story that I can share with you guys. I once worked at a shop where all the time I was being told to put a fuel filter on a car because it could be restricted. And if you live in the northern climate, the Rust Belt like I do, and you have a screw-on type of fuel filter like this guy, a lot of times that's a big chore by itself, trying to get those lines unscrewed without breaking the fuel lines. So I came up with this idea, and it's not a real, earth-shattering idea, but technically, if this fuel filter, is restricted, 2 things are going to happen to that waveform. Number one, it's trying to pump fuel, but it's hitting a mechanical restriction inside here. So now that fuel pressure is fighting to overcome that mechanical restriction and it backs up. And when it starts to back up, the rotational speed of the fuel pump actually slows down as a result of that. Also, because it's trying to overcome a mechanical restriction, the amperage is going to go higher, right? So this would require you knowing what known good values are for the speed and the amperage. So a little bit of testing on your part, on some known good cars, much like a lot of the diagnostic tests we do requires. But once you know what those are, now you can say, hey, is this fuel filter actually restricted? Because the other way to test it would be to take it off the car and try to blow through it, right? And that's a lot more work involved as opposed to just, clipping an inductive amp clamp around either the power or ground feed to the fuel pump. So I put a little thing up there that you guys have probably seen at this point that is telling you how to determine. So if you know what your scope settings are, and you can go ahead and determine how many commutators there are on the fuel pump, you'll be able to do this same type of test. You'll be able to tell the overall RPM and amperage of that fuel pump. Now let's get back to what we were talking about with fuel pump relays. And a fuel pump relay, wherever the relay happens to be located, so here's a Chrysler product. I'm just holding this up as demonstration purposes here, but here's an actual fuse and relay center. So let's pretend like it was, this relay here, which I don't know if this is the one or not, but for sake of the video, that's fine. So if you ever look at a wiring schematic, you know, this is an ISO style relay, the old-fashioned style, where it basically has pin 30 and 87 and 85 and 86. But if on every relay, there's always a little schematic, and that little schematic always tells you what the switching one is, right? So the two that would close, when the contacts close, that's going to send power back to whatever it's trying to power up. In this case, we're using a fuel pump as an example. So it's real easy to test these guys. These aren't very hard to test. You know, you could switch them out with another one that's right next to it, whatever the case happens to be. But there's a lot of diagnostic value in saying, hey, is the circuit working, right? So if you tested this and this is good, now if I go inside there and I jumper that switch circuit, so in this case it happens to be 30 and 87, if I jumper those two, that would be the same as if this relay closed inside there, and whatever that is hooked to on the vehicle should start to activate. So in this case it would be the fuel pump. You should hear that turn on, right? So how do you test the circuit is a quick little thing, because you're basically taking your diagnostics and cutting it in half. Is it a problem with the wiring or the component, or is it a problem with the switch side of the circuit? So that's where you have all the different types of relay testers that are out on the market. So, you know, over the years, these different types of relay testing circuits have evolved. So I could take something like this. It's got a little on-off switch, would be the same as you jumpering those two terminals. It also has an inductive amp wire going around it. So I can take and put my inductive amp probe around there and get an amperage reading once I turn the thing on. So I love this style because I don't have to sit there and babysit it, and plus I can measure the amperage, right? There's also the style that AESwave produces. This is called an uActivate, and it comes with a whole bunch of different harnesses and stuff. It's got all the different meter leads, but notice it's got the inductive amp clamp loop around it as well. So I can go ahead and do the same type of scenario as this kit of relays. Now, my dislike of this kit of relays is, if you've been in the automotive industry for any length of time, they keep changing the relay design, right? So, you know, this one has 6 different relays that came in the kit. I like it, but sometimes I go to take a relay out of a fuse block or whatever, wherever it's located, and I'm like, well, it's a different design, right? It still operates the same way, but it's a different design, and I don't have something that's made to actually plug right into the thing. And uActivate does have more of a choice of the harnesses that it comes with to be able to substitute that. Or you can do something that I did this years ago after the frustration of them. The auto manufacturers keep changing the fuel pump relay designs or any type of relay design, and I just made a universal relay tester, right? So, you know, I got a fuse protected. If you didn't want to have a fuse protected, not a big deal. I've got the amp loop on there. Obviously, this button will turn the thing on and off, but then I just got 2 leads coming out of it. And these 2 leads here, I can just go ahead and say, okay, no matter what type of relay it happens to be, I look at those closed contact part of the schematic on the relay, and I just put these 2 leads in that scenario there. And now I can just go ahead and push the button, right, and hook up my amp clamp, do all the testing and stuff. So that's something you can make as well. It's not that difficult of a tool to actually make. So the relays are important, and if I push the button on any one of these things or flip the switch or whatever the deal happens to be and the fuel pump were to start running, I know that the problem is with the switch side of the circuit. If it doesn't run, then it could be a harness problem going down to the device, or it could be a faulty device, like a bad fuel pump in this scenario. All right, so now let's continue back with fuel injection, is how it's evolved over the years here. And we came out next with something that was called a throttle body injection. Now the throttle body injection would have either 1 or 2 injectors, right? These injectors were usually low resistance style injectors, and this was called a peak and hold style injector. So what that basically meant was it was just constantly pulsing on and off over and over and over again. And then as we open up the throttle plates, whichever cylinders needed the fuel, it's just like the old-fashioned carburetor. We're just taking the atomized fuel at this point, because an injector has got a very small opening from the pinhole. We're spraying it into the intake manifold, and through vacuum, we're sucking it into the cylinder, who's got an open intake valve on it at that point. As you can see, it's still a mechanical style design, so you still have that disadvantage like we had with carburetors, and we're still relying on the puddling effect from the intake manifold. So there were some disadvantages to the throttle body type of injection here, but it was still way better than carburetors because we didn't have a choke anymore. The coolant temperature sensor acts as the choke on a modern day car. We also didn't have to rely on heat to help atomize the fuel because it's the fine opening pretty much is creating atomization as it's being sprayed into the engine. Now that waveform, a voltage waveform from that, looks like what you see on your screen now, where we basically are creating two types of voltage spikes. So to measure that, we would measure from when the voltage dropped down all the way over to the second spike. During that time is when we were charging the fuel injector and actually spraying fuel, and then obviously at the end of the second spike, we turned it off. So why does it create a spike, and what's going on with the voltage level being dropped and everything else? I used this as an example in one of the earlier diagnostic videos, but I used that garden hose as an example. You've got a lot of water pressure holding that squeeze type of garden hose closed, right? The pintle on that hose closed. It takes an amount of force to overcome that water pressure holding that closed. So you got to squeeze it a little bit harder to get it to open up to overcome that pressure that's holding that pintle closed. But once you've actually squeezed it and water starts coming out, you don't have to squeeze it as hard anymore, right? You just got to barely kind of hold on to it to allow it to stay open. So that's what we're seeing here through representation of using a scope, that it took, let's say 3 amps or so to overcome the fuel pressure that's holding the pintle on that injector closed. But once it's open, it doesn't take that many amps anymore to keep it open. So that's why we had the 2 spikes there. So those had problems too. Fuel injection was relatively new. We could have, shorted injectors and stuff. Over the time, we've evolved, and a lot of the common problems with fuel injection has kind of fallen by the wayside. Now, the problem with that was it was way better than carburetors, but it wasn't quite as good because we were still polluting the air greater than what we could do if we went to 1 injector for each cylinder. So again, this is all the evolution here. So we came out with something called a multi-port fuel injector. So we would have, 4 injectors, 6 injectors, 8 injectors, however many cylinders there were on a car, and each one of those cylinders would have an injector on it. Now, we did not have camshaft position sensors back then, so what this would do is this would spray the fuel 2 times per 4-stroke cycle. Not a big deal, right? It was better than throttle body, where we're just spraying like crazy. Once the intake valve opened up for that cylinder, it would suck in both of those fuel sprays into the combustion chamber. The disadvantage to this was, well, that puddling of fuel on a closed intake valve before it opens up for the second spray there, well, that develops a bunch of carbon. So now carbon acts as a sponge. So if I got fuel and I got a bunch of carbon inside of a cylinder, whether it's inside the cylinder, on the back side of the intake valve, whatever, I'm spraying fuel in there, but a lot of that fuel is being soaked up by the carbon, which means that the cylinders would run a little bit lean. We used to have to clean injectors all the time. There was a lot of companies out there making injector cleaners at the time, and that was a big service that we would do. That would cause the cars to run rough, possibly misfire, a whole host of drivability type of problems. So that was the port fuel injection. Now, that type of waveform, along with sequential fuel injection and other types of waveforms, did away with the 2-spike system. That wasn't a saturated switch style type of injector anymore. It was either on or off, right? So what we did here, you can see on your screen, this is how we'd look at this type of waveform. This is a voltage pattern again. So we are requiring some amperage, just like always, to actually open up the injector. But now when the injector turns off, we only have the 1 spike. So once that injector turns off, then we're just waiting for the next time for this. It was told by the PCM to go ahead and fire these injectors again. Now we have a better way to test fuel injectors. So we got the voltage pattern. It's important for all of us to understand what those voltage patterns are relating to us, because if I had a voltage pattern and I had a shorted injector, well, the voltage spike is going to be different than from what a known good injector pattern would look like and stuff. But we're only seeing when the computer tells it to turn on and when the computer tells it to turn off when we're looking at a voltage pattern. But we know that even though we're ramping up current inside there to overcome that fuel pressure holding the pintle shut, it doesn't actually open until there's enough current to overcome that holding of pressure there. So we have something called a pintle hump, and that's when it's actually opening. There's current is high enough inside this injector now to actually overcome that fuel pressure that's being sent to the top of the injector, and now it opens up and fuel starts to spray out of the bottom of it. So that's known as a pintle hump. So if I use a low amp inductive probe, I can see that when that pintle hump actually starts spraying fuel. So even though we're charging that coil of windings inside that injector for a longer period of time, we're not actually spraying fuel until we see that pintle hump. So why is this pintle hump so important? Well, this goes along with comparing it to your scan tool data of what's called millisecond pulse width, right? That millisecond pulse width is the amount of time you're actually spraying fuel, and if you were to take the cursors on your scope and line them up to an injector amperage type of waveform pattern there, that would line up perfectly from when it's actually spraying fuel, when it begins to spray fuel, to when we tell it to shut off. Now the second part that's circled there, that represents when the injector is told to turn off. So I had some comments in some videos that says, you know, I just got my butt kicked on. I thought that I had a restricted injector and stuff. Other scenario could be, it could be a leaking injector. So we're going to talk about all those scenarios as we go on throughout this video here. But we'll come back to this. That's a great way to tell if the injector is actually turning off or if it's leaking or anything along those lines. Then we came out with sequential fuel injection. Basically the same style injector. These are usually 12 to 16 ohm injectors, right? Same style injection. However, the difference is we came out with something else that's not really involved with the fuel system, but we had a camshaft position sensor. Now once we knew where the camshaft was located, now we say we don't need to spray it 2 times and just have a bunch of fuel puddled on the back of a closed intake valve, because I know exactly when that intake valve is going to open per cylinder. So sequential fuel injection came out. That did away with a lot of the carbon cleanings and stuff that we used to have to do on vehicles. So the cars started running even so much better. And this is just how everything's evolved. There is another type of fuel system out there that's not real popular anymore, but this was called CPI, central port style injection. This was a big time General Motors type of thing. What this did is the bottom part here were actually called poppet valves, and each one of these would go inside the combustion chamber of one of those vehicles. Now I had the electrical injectors on the other side of this. I also had a fuel pressure regulator hooked up to it. Didn't have to have a vacuum hose on it because this is all down inside the intake manifold. Now these actually, even though this was central sequential, which means it should only be spraying fuel 1 time, these had a bunch of carbon problems as well, because the tips of the actual injector part itself, the poppet valves, those were exposed to a lot of carbon inside there. So these, if you've never come across one of these, you may not, because those aren't very popular vehicles anymore. A lot of them are, in salvage yards and stuff, but those were another style. We have 2 styles of that. The first early style was not actually sequential. The later styles actually incorporated in the sequential style injection inside there. So again, the basic fuel test of testing fuel pressure, fuel volume and stuff, that would apply to any one of these systems, even a carbureted system. However, once we start getting into the testing the actual injection part, that's where it's going to differ from one type of system to another. So when I test an injector, so you might say to yourself, okay, so we've been talking a lot about injectors, how can I test it? So we all know that one way to test it would be with an actual ohm meter. And I can test the resistance, the coil of windings that's inside that injector. And that should tell me if it's shorted, if it's open, anything along those lines. Any one of my videos, I always tell you, I hate doing static type of tests like that because there's no actual current flow happening here. So just like when you have a no start and you're wondering am I getting a signal from the PCM to tell the injectors to turn on and off? That signal is usually coming from either the cam or crank sensor. They had these little guys called Noid lights, right? So there's a different set, and depending on what type of terminals they had for the injectors, you would just find the one, plug it in, and while you crank the car over, it should be blinking on and off. But again, it's not a loaded test. That was the downside to this. It's a quick go or no-go test, but it's not a loaded test. So just testing the resistance of these guys, this would help me determine if I had shorted injectors and stuff. That was a big problem back on the early General Motors cars, where injector drivers would short out because you have one or two bad injectors on the vehicle. Sometimes you'd have even more than that, and it caused all kinds of drivability problems. But there was a couple companies back in the day that had these really cool tools that were, I'm not seeing it, but I'll find it for the second part of the video, that was really cool, that would allow you to do a loaded test on here. So you'd hook up your, company was called OTC. Here it is, I found it. So I'd actually take this tool and I'd do the same type of test result. I'd have to have power and ground, right? So I'd hook that up to my battery cables on the car. I'll show you this in action here when we get to the hands-on part. And the other lead coming out of it would just simply plug right into the injector. And it had some adapters in case the injector leads were different. Then I'd put my voltmeter leads inside here. So I could turn it on ohms and just get the same type of static type of test results of, let's say this thing turned out to be 12.3 ohms or something of resistance. But the difference is I can then go ahead and flip my meter over to the voltage scale, and I can do a voltage drop and actually select the amperage scale depending on the resistance of the injector, push the button, and now I'm doing a loaded test, right? Which was a huge benefit. I didn't have to take the injector off the car to do this. I could do it right on the car, very simple and easy to do. So I'll show you that in action. I don't know of any manufacturer still making that tool. So you got to be old like me to actually probably have one of those in your diagnostic arsenal there. But that's another way to actually test the integrity, the electrical integrity of the fuel injector. Now again, if you're using a lab scope, you get a good insight as to whether or not this injector is shorted or any of those kind of problems that we used to have to do with a tool like this. With modern day technology of looking at the waveforms that a lab scope displays for you. Now, we also would like to do an injector flow test. So one of the comments that I just recently read said it was a Toyota Prius or something that, had some restricted injectors. And how can I test that on a car without having to take the injectors out of the car and put them in a flow bench, or even if you don't have a flow bench, somehow physically watching it. So I'm going to show you guys how to do an injector balance test on a vehicle. So we can power up and develop fuel pressure into the fuel rail, then we can one by one turn the injectors on, whether we're using an old-fashioned tool like this or whether we're taking advantage of the bidirectional controls of our scan tools. So now every time I turn an injector on, it's going to drop so much fuel pressure. And then I go to the next injector, it powers the fuel pump back up, get the fuel pressure back in the rail, and then I'm just going to be recording those results of each one of those injector drops, which is going to tell me if I have any type of carbon possibly restricting those injectors. We can also use a gas analyzer. A gas analyzer's got a lot of benefit to it. I'm going to have a section of these advanced diagnostic videos that talk about all the benefits and how to use a gas analyzer and stuff. It's not just for emissions testing, but let's say I had an injector that wasn't shutting off, right? So it was a leaking injector. Well, that's not a problem if you have a gas analyzer, right? I can take the spark plugs out of the cylinders, and I could take the wand from my gas analyzer and stick it in each one of those holes. And if I had a leaky injector, gasoline has hydrocarbons, right? So hydrocarbons value is going to start to skyrocket in the cylinder that has the injector that's leaking fuel, right? I also can actually do a dynamic test with my gas analyzer by doing an injector balance test, and instead of looking at the fuel pressure drop, I can actually look at the hydrocarbons readings, right? So if I go ahead and I tell an injector to shut off, I should see a difference in the hydrocarbons coming out the tailpipe on my vehicle. I also have flow benches, which we're going to talk about this guy here. This is probably the best way because now I get a visual representation but it's also the most time-consuming way to actually test a lot of the injectors because you have to remove the injectors from the vehicle. Some cars that's easier to do than others, as you guys are well aware. All right, so with that being said, I got some fuel system tips and tricks that I'm going to share with you guys real quick. And I'm not going to read these word for word or anything, but these are common problems and shortcut ways of addressing some of these problems. So one of the big things that we'll leave this up on the screen so you guys can read it, but one of the big things is if you have a shorted injector, a lot of times you can do a little trick where if you take a battery load tester and load down the battery, that extra load you're placing on the charging system will help to uncover that shorted injector. Whether you're using a scope or an old-fashioned tool to determine if it's shorted or not, doesn't matter. It's a good way to actually find those injectors that are a little bit harder to diagnose as having a short on there. Also, if you do have shorted injectors and stuff, the idle air control or whatever they want to call it on the manufacturer type of vehicle that you're working on, those IAC counts are going to give you an insight as to whether or not there's a shorted injector on it. Carbon buildup is always a big concern, especially with gasoline direct injection coming to fruition on most of modern day cars. So that carbon buildup is something that we got away from with multi-port fuel injection, but it's coming back as a pretty much a common day problem where we have to address that on modern day cars. And again, I told you in part 1, all my little 6 go-to PIDs and how I can use fuel trims to help me diagnose if it's a fuel-related problem or if it's an ignition-related problem. So again, I'm not going to read these word for word. You guys can kind of see them, but I got a couple different screens of the little fuel system tips and tricks in general, whether it be with the conventional fuel pumps and stuff, or whether it be with special fuel injection systems, whatever the case happens to be. So now let's fast forward into more modern day times here. Gasoline direct injection. What's the difference between that? Well, on a gasoline direct injected car, the injectors look different in appearance, right? They're usually a lot longer, but the actual part that sprays the fuel is directly inserted inside the combustion chamber, as opposed to going inside the cylinder head waiting for an intake valve to open up. So because it's directly located inside the combustion chamber, well, that's where all the extra carbon's coming from. So the tips on those get, carboned up on a relatively regular type of basis there. So you'll notice from the screen here how this kind of looks in a cutaway engine that I got from one of the car shows that came to the Cleveland area here. They had these engines on display when GDI was pretty much brand new. So part of this is also, it's all integrated together, right? So if you notice the top of that piston there, the fuel as it sprays inside the cylinder, that cutout in the piston is actually directing all that atomized fuel right to that center electrode of that spark plug. So we're going to have the most efficient type of fuel injection system with gasoline direct injection. And atomization has really improved because we've got even higher pressure. So with even higher pressure, the fuel molecules want to atomize much better. Again, there are some disadvantages to this, one of them being carbon. That's the biggest disadvantage. Another disadvantage is the extra fuel pressure becomes a danger or a concern for us as technicians. So we have a low pressure fuel pump that is going to basically take fuel out of the car at 30 to 60 psi roughly and pump it up to the high pressure fuel pump. Now this high pressure fuel pump's being driven off the camshaft, right? And it's kind of operating just like an old-fashioned carburetor type of fuel pump where it's got a lever of some sort. So there's going to be an extra lobe on the camshaft, probably have a little lifter of some sort inside there that's actually pumping this. Now that actual pumping method here takes that 30 to 60 psi and increases it exponentially, right? It could be a couple hundred psi, it could be, over 1,000 psi depending on the car and the driving conditions that you're working on. So here's where the low pressure fuel is coming into the tank. There's my little low pressure fuel test port with the cap still on it here. But on the outside of it, it can't use any kind of little push style connectors like we're used to with the lower pressure systems. Everything is screwed down and in place. And these are one-time use lines. So the reason why they're one-time use lines is because once I torque it down, it's going to distort that ball shoulder type of socket there, which means I'll never get it to tighten down with the exact same distortion. So it's going to want to leak, right? Because we got such higher pressure. So if you take this apart, let's say somebody comes in for a head gasket job or something, and you have to take all this stuff apart to get the head off, well, that means keep that in mind when you're pricing out the job, that you're going to want to include the money in there to replace whatever high pressure fuel lines that you had to disconnect or disturb throughout that process there. Now, with that being said, I've got at the bottom there 3 fuel injectors. You can kind of see the center one has been cleaned up. But the 2 outside ones, that's what the inputs or the outputs of the injectors look like, where they have all the carbon built up on there. Also, anytime you service a GDI system itself, so you're changing an injector or doing whatever the case happens to be, there's little clips that hold the injectors onto the fuel rails. So here's a fuel rail with an old-fashioned type of car, and we all know that the injector would pretty much just kind of push into place. This style has an O-ring. The new styles usually have like a Teflon O-ring, much better design. And then there'd be like a little clip that would kind of hold this in place. Well, you want to change those clips out too if you start to disturb any of this. Always want to be changing the seals anytime you pull the fuel rails or anything out of those vehicles, just for safety reasons because of the higher fuel pressure that's involved. But this is how that high pressure fuel pump is actually designed here. So here we can see this is a little cap that would go on this particular car on the back side of where the camshaft is actually exposed. In the bottom corner, you can kind of see how there's a cam lobe that's going on that roller lifter. So a lot of times you'll get some trouble codes that has to do with the high pressure fuel system. The car will still run with the low pressure system, but you'll get some trouble codes, and it might be that the camshaft's worn out, right? Or it might be that the lifter's worn out. You can kind of see, I know I didn't get a real good picture of this from the auto show, but there is wear on that roller lifter tip there. Because we're dealing with such higher pressure, there's a lot more fumes involved, so you don't want to be smoking around these systems, anything along those lines. You want to pay attention to safety because you can actually inject that gasoline, pierce your skin, and go right into your hand or whatever with this. So if you're working on a vehicle and you start to crack open those screw type of lines of the high pressure fuel system, it's like being shot with a fire hose, right? It's a lot higher pressure than getting shot with an actual garden hose. So the volume of pressure and the overall pressure is very dangerous for us. So we always want to make sure before we open up a fuel system, a high pressure fuel system, that we go ahead through our scan tool, read the fuel rail pressure. There's no way for us to get a mechanical reading on a high pressure system, a GDI system. We can get the low pressure side, that's the one that's coming from the gas tank up to the fuel rail, but there's no way to get this mechanical wise. So there's a little sensor that's going to be on the fuel rails that's going to tell you what the high pressure of the system happens to be. So you take your scan tool, you plug it in, you look at that fuel pressure, and if it says that it's 800 PSI, 1000 PSI, whatever the value happens to be, you want to relieve that pressure before you start to crack open those fuel lines. So you could do that a couple different ways. The easiest way, I mean, sometimes your scan tool, if you got a halfway decent one, allows you to do that bidirectionally. But let's say it doesn't. You can just find that fuel pressure relay that we were talking about, pull it out of the car, and crank the car over. The car might start for a couple seconds. It may not start at all. But just watch that data stream on your scan tool until that pressure gets down, to 40 PSI or less, because we've all taken fuel lines apart that were 40 PSI. It's not going to pierce your skin, cause any kind of problems. So there's a couple little housekeeping type of things when we're talking about gasoline direct injection. Because of the carbon that's going to be built up inside that combustion chamber around where those fuel injectors go, it's also very hard to get those injectors out of the combustion chamber. So there's a lot of companies out there, OTC, Lyle, a lot of different companies that make little kits to help you pull them. So if you've ever taken injectors or glow plugs or anything out of a diesel, you kind of already am used to this, right? You got to overcome that carbon buildup there. So I'm showing you again, the carbon issues are the biggest problem with any vehicle that has gasoline direct injection on it. Another little housekeeping rule of thumb that I can say is when you take the engine covers off a modern day car, gasoline direct injection, you hear this. You hear that clicking of this thing going back and forth. So those engine covers are made so that the car owner inside the car doesn't want to hear that. It sounds like you got a bad lifter on an old-fashioned car. So, and the way how all the wiring and everything is all laid out, they don't want nothing touching the fuel rails, because if anything's touching the fuel rails, the harmonics of that clicking that you're hearing of this fuel pump actually get exponentially louder, and it kind of works as like a microphone. So if you take something apart, put it back together, make sure the hoses, the harnesses, everything are back in their little wire looms the way how they're supposed to be. Definitely put that engine cover back on the car. You know, don't leave it off the car for any reason, because the customer is going to come to you and they're going to say, hey, I think I need an oil change or something because it seems to be ticking or something. And sometimes you still get that, right? Sometimes your customer comes in, maybe they were outside of the car, so they pulled in somebody's driveway, they got out of the car to go knock on the door or something, and now they're hearing as they walk, you know, to the door on the guy's house, they're hearing that clicking or ticking, and they're like, oh, my old car didn't sound like that, right? So sometimes they bring it to you and they say, hey, it's making this weird noise, but that's a normal scenario. They just don't hear it while they're in the car, because number one, they're in the car, number two, that engine cover is primarily designed to help cut down on that type of noise there. So here's another picture of different types of wear patterns. This is a more close-up of different types of wear patterns. So there's a worn cam lobe there. If it's got a lifter of some sort, so this is a European car and they got these little covers that go over it, you can kind of see how the wear pattern gets displayed there. So it's vitally important that we always use the correct oil when we're dealing with these cars. So it's not just something that the oil fill cap tells you to use Dexos or tells you to use a specific type of oil. You definitely want to do it because we don't want this to fail on us. That's a very costly type of repair for the consumer that has a car, and maybe they took it to some discount oil changes and they weren't using the right viscosity, or they didn't have all the certifications of the oil, whatever the case happens to be. So the oil quality and content and everything is of vital importance there. So at this point, what I want to do is I want to turn our attention to do some stuff on the car. We're going to do some stuff with the scan tool. We're going to do some stuff with the scope. We're also going to concentrate on doing this because a lot of the stuff that we talked about, I can show you with a really good view of using this type of tester right here. Okay, so we're going to start off relatively basic with our tests here. And I'm going to use the special fuel injector tester from the old days. You don't need that to do this first test. It's just a static test, so I have it hooked up to the fuel injector, just got it plugged in. I could take my 2 leads for my meter and just touch the 2 terminals on the injector. But I'm going to put it in there, and you can see that from the meter screen, we're reading roughly about 16 ohms or so. So that's the static test. Again, I don't like static tests because it's not being put under any type of load. So instead of hooking up the other 2 leads of this tool to the car's battery, I've got this little 12-volt power supply. I'm just going to power the power supply up. And basically what I'm going to do is I'm going to put my meter on voltage. And now I'm going to do an actual loaded test. I could do a coil test or a balance test. I'm going to select 2.5 amp of the balance test, and I'm getting a reading of the voltage drop. So we know we're giving the tool 12 volts. With the resistance that's occurring through the injector there, I'm seeing the voltage drop, so it's an actual loaded type of test. I can hit the little start button on here, and we can see what that does to our reading there, and we can see that that voltage drops even further once we were to tell this injector to actually open up. Now the balance test on there would actually cycle the injector, so it'll want to pulse the injector, kind of like if we were using the Noid lights from in the past to actually go ahead and spray the actual fuel out of that fuel injector. Now that's a great test for doing an injector balance test or an injector drop test on a car. Again, I'd fill up the fuel rail. I got a better way to do it, which I'm going to show you using the scan tool and also a fuel pressure gauge. But that's another way. If I didn't have a scan tool, if I had a tool that can actually pulse the injector, I'll be able to do that same type of test. I just have to cycle the key each time to build up fuel pressure again. Now the other test I wanted to show you here was just acquiring a fuel pump waveform. So I got my low amp inductive current probe here. I got this from AESwave. This current probe, by the general look of this, you can find this made by many different manufacturers. So you can find this exact same current probe that has the words OTC on it, and you're going to be spending close to $400 for that thing. Or you could buy this one here from AES, which is a much more affordable rate. It's the exact same current probe. So that's a good thing. So I'm going to turn the scope on, and we're going to hook up to this fuel pump that I got actually oscillating on the bench over here. So I'm going to power up the scope. I'm going to say okay there. It wants to perform a little update for me, so that shouldn't take a real long time to do. We're already at about 50-something%. So once that's done, 100% there, the scope, that should go away, and we should see the scope pattern better. All right, so let's go ahead and hit the scope button again. Now, it's searching for the device. It's going to read the data, so it's connected to the scope module that I just have on the dashboard of this car. I don't much care about channel A because I got the scope actually in channel B, so I'm going to go ahead and turn channel B and focus our attention solely on channel B right now, turn channel A off. And again, for this particular scope, I got to tell it that I'm using some type of inductive amp clamp. So I'm going to go to probe setting. I'm going to scroll on up the list here. I'm going to use my 65 current clamp with the first rating here. I'm going to say, okay, that all looks good. Now again, the scope is in auto sampling. So as soon as I clamp this around one of the two wires there, I'm going to start to display a waveform. It's not going to look pretty because it's in auto sampling. I'm going to have to make some scope adjustments here. Whenever I'm measuring current, current is the same whether you're on the positive or negative side of the circuit, which makes hooking up a clamp like this very easy. So it doesn't matter if I went to the power wire or the ground wire. I'm just going to clamp around here. And again, it's in auto setup right now, so it's trying to display some type of pattern for me. What I'm going to do is I'm going to make this a little bit more user-friendly here. I'm going to adjust the time base, and I'm also going to adjust the voltage scale here of the actual probe setting here. I'm going to go down to, let's say, 10 amps. And let's see if I get a better looking pattern here. So this would be more custom to what I'd want to see for this fuel pump. Now, in all reality, there's no fuel pressure going to this, so the amperage and the RPM is going to be a little bit different. Plus, this is a low pressure pump. So we're still seeing what I like to call those little camel humps there. And if I wanted to determine the RPM of this type of pump or anything, what I'd want to do is I'd want to look for a different pattern, right? So I can see that I've got some voltage spikes going up on a couple of those waveforms there. But in particular, there's a series there where it repeats itself several times. So I'd want to count how many humps I have before it repeats itself. And then I could determine how many segments of that commutator there was inside that fuel pump. So here's real quick, you saw that this took maybe 4 seconds to actually hook up to. Now granted, this pump is on a table, but again, think about everything we talked about. Remove the fuel pump relay with one of our relay testers that has the amp loop, put the fuel pump relay in its place, flip the fuel pump relay tester on, and then just clamp this right around that amp loop, and it still doesn't take any amount of time. And again, I can determine stuff like, was this the cause of the no start? Is there a bad part of the commutator segment in there? Is there a restricted fuel filter? All that stuff can be determined with one quick, simple hookup underneath the hood of the car. Or if it's easier, if the car doesn't have a very easy access to a power or ground wire to the fuel pump, sometimes it's easier to go underneath the car. Most of the time, though, it's going to be easier to go underneath the hood of the car as opposed to lifting the car up in the air. So now I want to focus our attention on this guy. This is an injector flow bench. It will also clean injectors. I can do all kinds of cool stuff, which I'm going to show you as the video goes on here. This is made by a company called Autel, very close to Autel, but it's a whole different company. So Autel, with the injector flow bench, I have the ability to not only test the injectors, I can clean the injectors. On the back side is an ultrasonic cleaner from the top. I could take the injectors out of the car, place the injectors inside that bath. I recommend this stuff looks like it's made by A-Team for the cleaning solution. This is not the stuff that we're going to see coming out of these tubes here, but this is what we'd be using in the ultrasonic bath there. And I can clean the injectors manually that way. Now, I don't have to take the injectors out of the car to actually clean them, as we're all well aware of. There's all kinds of other companies out there. I happen to have one by Lang. Here I would just pour that injector cleaning solvent inside of an on-car type of cleaner. Bernie Thompson from Automotive Test Solution has a whole GDI cleaning type of setup. So whatever you have, there's options to cleaning the different types of injectors that you may come across here. But cleaning the injectors, again, cleans the carbon buildup off of it, especially if they're restricted injectors. So every time you tell the injector to open, it can't spray the fuel out because of the mechanical restriction. And plus, remember, carbon acts as a sponge, so it sucks up some of the fuel. What's nice about this flow bench here is the injectors should be matched. The flow rate of the injector should be matched from the manufacturer. And over time, as they get restricted, you will actually see that. You'll also be able to tell if the injector is shorted. You'll be able to tell a whole host of different problems. Plus, when I'm cleaning the injectors, I have a couple ways that I can clean them. I can actually clean the injectors the conventional way, where the flow comes in from the top and then comes out the bottom. But I can also go ahead and do a reverse flow type of test on the injectors, where I can go ahead and back flush the injectors as well. This tool is worth every single cent. Now, there's other manufacturers that make a flow bench like this. One of the companies out there is a company called Launch. Launch makes a tool like this as well. What I love so much about this tool is it's capable for doing conventional style injectors, whether they're throttle body, port, or sequential. But it also, you'll see it's a new modern day version where I can do gasoline direct injection, which requires a much higher voltage to turn them on and off. So it comes complete with all that, and it's a fraction of the cost of some of the competitors' tools that are on the same market here. It does the exact same thing. So you can kind of see I got a couple different things. Function one is just ultrasonic cleaning. That is if I had the injectors in the bath in the back. It's going to pulse the injectors on and off, and it's going to rattle them around to help clean the injectors. A very, very precise way, and what's nice is if you choose this way to clean it, you can test them before the cleaning and after the cleaning to see the actual difference that's occurring here. I also have idle tests. I have medium speed test, high speed test, acceleration test, a leak check test, which is very beneficial. I'll come back to that. Medium speed spray value test, high speed, reverse flushing. So I have several different types of testing of the injectors that I can do. Now, I'm not going to go through all 4 or 13 different types of steps on here, because I think you'll get the general gist. Each one is going to do something different. Now, all of those different speed types of tests is going to affect the rate at which this is actually going to pulsate those injectors. So obviously at idle, you're not going to have as much fuel flow or anything. At high speed, you're going to have a much higher fuel flow rate. I can also adjust the pressure going to the injectors. That's with the actual pressure buttons over here on the side. So depending on the type of injector, if it's throttle body, it's going to be a lower type of pressure. You'd kind of want this to emulate whatever that original fuel pressure is. So it's not going to go up to 1,000 psi, but for gasoline direct injection. But remember, on those GDI cars, you're giving it, roughly, let's just say 60 psi or so of pressure, which I could definitely acquire that type of pressure. And then the high pressure pump is what's actually boosting it up on GDI from there. The little drawer, the little storage drawer, I love that. It's got all the different types of injector type of adapters inside of it. Comes with, the different O-rings and stuff for the sealing of it. So it's a very complete kit overall, in my opinion, and I love this because it's great not only for servicing and repairing vehicles and being able to diagnose them, if the problem was an idle-related problem or whether it was a high-speed problem, I could simulate those exact same conditions, but it's also great for the training environment, so you can actually see what's going on. So before I power this up, I'm going to do it a couple times because of how this is designed. Some of these little flow measuring tubes are recessed inside the machine, so you can't actually see them, but you can see that they're graduated. So in essence, when it's done, after each one of the tests is done, I should be able to match up the actual volume of fuel that's actually being sprayed there. So we're not actually spraying fuel, we're using odorless mineral spirits inside the machine here for the flow test. But you can also see the injector spray patterns. Now these are all the same injectors. They came out of a car, they should all be properly balanced and everything, and they should all have the exact same spray pattern if they're not restricted in any way. So once I turn it on, you'll be able to see the spray pattern, and if you see it coming out like a actual water hose, that's not good. You should see like a conical type of injector spray pattern on most injectors. Not all injectors come out like that, but on most injectors, and you should see the atomization that's occurring here. So just for sake of video, I'm just going to select function number 10, which is a high-speed test, and I'm going to say go ahead and start it. I've got the pressure adjusted to about roughly 50 psi on here. Now we can actually see the injector spraying the fuel. So I'm looking primarily at first up at the top, and we can see this one definitely is spraying, has a much longer spray pattern in the center, and I can see the atomization occurring, but this one here and these other ones have a better atomization, not as much of a cone-shaped spray pattern. Injector number 1 over there is probably the weakest out of all 4 of these. So this could be the reason why you have a cylinder number 1 type of misfire complaint. I'm going to do it a couple more times. I can adjust this working time so it stays on longer. But I'm going to do it a couple more times so we can actually see the actual fluid as it rises up coming out from the little recess area here. This is only going, it pumps it down to 10 on the actual setup here. And I also have the actual pulse width adjustment. So I can change the pulse width on here. I got the little up and down arrows, so I can make that pulse width either faster or slower. I'd have to do that while the test isn't running to actually have that number change. And I also can adjust the actual injecting time here that it's actually being displayed. So if I were to change this and say, hey, let's make this run a little bit longer, let's go up to 20, so we doubled it. And the pulse width, let's make it so it's a little bit more than what we had before. I think it was 10 before, so let's do 11. And then I'm going to go ahead and hit the start button again. And now I'm spraying the fuel again, but notice by just making those changes of the pulse width, notice what that does to the actual spray patterns there. And this is just like how your car actually operates. So that's the real theory and benefit of using an injector flow bench. I can simulate the car's operating conditions under different types of driving conditions, whether it be idle, whatever the case happens to be, and I can actually physically see the actual flow patterns. And I can see that this one here in the middle is probably the one that I like the best out of the 4 that are being displayed there. Now, if I wanted this to fill up, I would have to close this. I've just got it circulating right now, but now it's actually going to start to, since I closed the little valve here, it's not going to circulate back in the machine, and eventually that you'll start to see that on the camera here. So I have a lot of different types of tests that I can do with this, and again, I can still do the cleaning. I can also do an injector leakage test. So let me explain that real quick. I'll let this run. It's not the injector leakage test, but I'll let this run so it just builds up that volume of fuel inside each one of those graduated cylinders. The injector leakage test, if I were to select that from the function menu, that's going to pressurize the fuel rail, but it's not going to send power to the actual injectors. So if one of the injectors was leaking fuel at the time, I would see that dripping down inside there. And that's going to cause, failed emissions tests. It's going to cause all kinds of problems like that. Running rich type of conditions, it's going to affect your fuel trim, obviously. Your O2 sensor values are all going to be skewed. So at this point, we can start to see the actual fuel levels. Once the test runs out there, since we're flowing liquid in there right now, we do have some bubbles. So once it actually stops flowing the liquid, you'll give it a couple seconds and you'll let the bubbles dissipate there, and then we can actually read it on the actual graduations there. And we'd want to make sure, again, all of these injectors should have a pretty similar matched flow rate. If they're not matched for some reason, it could be because of an injector electrical problem, such as a short or an open or something along those lines, or it could actually also be from a restriction problem. So if I was going to take these out of the car and follow the manufacturer's specs here, I'd probably first hook them up into the front part of the machine here and do a leakage test on it. Then from that point, I'd probably go ahead and do an overall flow test and then get some type of baseline reading. And then I'd take them back out of here. It's real simple. You just undo these little knobs here, pull them out, pull the injectors out, put them in the bath in the back. Again, I'd use a different type of fluid for that. I'd use the injector cleaning fluid, put them in the bath in the back, let it do its ultrasonic cleaning. Again, I have control over the time and the pulse rate and everything for every one of these tests. I'd clean them and then I'd put them back in here and I'd do the same type of test again to make sure that I made a noticeable improvement in either the way they flowed or by looking at the injector patterns, or maybe they were leaking before and they're not leaking now, or possibly the flow rate was just all screwed up. So looking at these right now, they're kind of balanced, but this one here, the third one, is definitely the lowest. I know you can't see the numbers real clear on the video, but this one's about 30, where the one right next to it on the left is probably about 35, 36. So there is a big difference between them. And if I went through the process of actually doing the cleaning and everything, I should see that those things should pretty much all be level and straightforward there. Again, this is made by a company called Autel, and this is a great, I can't give a shout out to them enough. They make some very, very good tools, in my opinion, and they are definitely helpful in diagnosing different types of cars for an affordable rate. So, this is just one tool, and they make digital voltometers, they make all kinds of stuff. So we'll be using a lot, not necessarily this company's, because this is the only tool I have from this company, but we'll be using a lot of different types of tools that this company does sell, just different brands of the tools, throughout a lot of our videos as we go through with smoke machine testing for EVAPs and so on and so forth. I mean, they got AC related tools, they got all kinds of stuff. So this is something that you can buy off Amazon, or I'm sure they probably have a website. I don't know, I never looked it up, but this flow bench is very beneficial. Technically, I can do on-car injector cleaning with this flow bench too, if I bought some hose adapter sets to be able to go onto the car. I didn't buy those when I bought this, so I can't, show you how to do that. I used my on-car fuel injection cleaning type of setup there. Another nice thing too about the on-car injection cleaning, a lot of times the throttle plates on the car get carboned up. We all know that that's a problem. So here's a little wand that I can actually take the air inlet hose off from the air cleaner, and I can put this in there and put the air inlet hose back on, tighten the hose clamp back down, and I can spray some injector cleaning onto the car while it's idling, which will help clean the throttle plates on the vehicle. So there's a whole oasis of different types of tooling and adapters and stuff. And again, you're probably maybe not going to want to run out and buy all the different tools you see in these videos, but I've been doing this for a long time. So I didn't run out and buy all this stuff all at once. It's over decades of me being a mechanic. So just, if you find something of interest and you think it's a good beneficial tool, shop around. A lot of times I started with the lower quality of a tool, and then eventually as I made money using that tool, I'd replace it with a higher quality, stuff that you guys have been doing for years anyways. So next what we're going to do is we're going to focus our attention on this vehicle over here. What I want to do is I want to do an injector drop test on this vehicle. I'm going to use my scan tool, and I'm going to use a fuel pressure gauge, and then I'm also going to hook up to a fuel injector on here. Now, the precursor to that is I've got the engine cover off, and this car, the way how it's designed, has a very unique thing with the mass airflow sensor hose. So once I take that off, I'm not going to have, it's going to run poorly, right? So it's going to run poorly. I'm not going to be able to run it for a long period of time. I'm going to set some diagnostic trouble codes, because in order to get at the injectors, I got to have that engine cover off, which means the mass airflow is not going to be able to suck any kind of air going past it. So I just want to throw that out there before we focus our attention on this car. But again, we're going to start with the injector drop test for one of the comments that we had earlier with that Toyota Prius. This is how I would do it. This is a very quick, easy way to actually do this test to determine if I had, you know, a dirty injector of some sort. Okay, so I've taken a conventional style fuel pressure gauge, hooked it up to the fuel rail on this plug-in hybrid type of vehicle. I'm going into my scan tool. I already communicated with the car. I select engine control module from the control unit. I'm going to use a bidirectional test here. That's going to be under active test. And I pull up a whole list of stuff I have control over. I'm going to go to fuel system. And what I'm going to do is what's called fuel injector balance test. So I'm going to click on the fuel injector balance test, and it's going to tell me some stipulations, right? It's going to say, hey, ensure that all the fuel lines are connected, all that kind of stuff. Connect the fuel pressure gauge up. Each injector can only be tested one time. I'm okay with all those. I'm going to say continue. Fuel injector 1 is going to be tested. So that's the first injector in the rail. I don't have to have a mechanical hookup to that fuel injector because I'm just looking at the drop that's going to occur here. It tells me once I hit the continue button, we're going to build up fuel pressure. So it's going to tell the fuel pump driver module to turn on and build up fuel pressure. And then I'm going to hit the start button and I'm going to measure. It should drop once that injector is opened. Once that injector is open, I'm going to record that drop and I'm going to go to injector number 2. And I would do that in this case for all 4 injectors. Obviously, if there's more injectors on the car, I'd do it for, 6 injectors, 8 injectors, or whatever. So I'm going to say, okay, we built up some fuel pressure. And I'm going to say continue. And then we see that fuel pressure is dropping here, right? So that simple test of just seeing the fuel pressure drop per injector is going to tell me if I have any type of restriction or contamination in any one of those fuel injectors. It always starts with the exact same key on engine off fuel pressure. The scan tool is doing it for us. Now, if your scan tool, let's say you don't have a bidirectional control scan tool, maybe the car doesn't support that test, you can do the same thing with an injector pulsar test and a fuel pressure gauge. So you could take that old-fashioned tool that I had. That would require you to unplug each injector and actually plug that tool into the top of the injector, turn the key on and off by hand to cycle the fuel pressure, and then just push that button and then record that drop. But to answer the one comments question, that's the most quickest, simplest way to do that type of test to determine if you have a restriction in any of your fuel injectors. Okay, so the last little quick test I want to show you on here, again, I can't stress enough, guys, there is so much more information available for every one of these subjects. I'm just trying to keep the video length in a condensed version. Full-fledged training classes are your real solution here. But what I wanted to show you is just looking at the injector pattern, both voltage over amperage. So I've got it hooked up to this car that's running behind me. It's not running 100% efficient only because the mass airflow does not have the hose hooked up to it at the time. I've got a frozen pattern. I've already sampled the pattern, kind of blew it up there. So again, the voltage pattern, it's both on the exact same injector. Now the nice thing is there's 2 wires going to the injector. One wire is actually, it doesn't matter because that's going to the inductive amp clamp, and it doesn't matter which one of those wires I clamped around to. The other wire is going to the voltage feed, so I have to be on the ground side of that pattern. So to determine that, I just had the scope live and I poked one wire first without looking at the actual wiring schematic. I just used a back probe adapter, slid it down. I saw that I had 12 volts on that wire, so that would not be the wire that I wanted. I want to go on to the other side to get that successful pattern there. So again, as soon as I'm looking at the red lead right now, the red picture, as soon as that voltage dropped down, that's telling it to start building up current in the injector, and the voltage spike that's occurring, that's telling it when I collapse the magnetic field and turn the injector off. However, that injector doesn't actually start flowing fuel until there's enough amperage built up inside the circuit. Now, if there is a shorted injector, that would affect that amperage, the actual inductive kick at the end, right? So that would be much smaller in appearance. If there was a shorted injector looking at the amperage reading, which is the green one underneath it, that's going to affect the overall height of that pattern. So that's going to be drawing a short, always draws more amperage. So I'm looking at the two patterns together. Notice they're both told to turn on at the same time, but the green pattern, somewhere around, I want to say roughly 0.58 on the scale there, is where I can see the pintle hump that's occurring on this pattern. And then once I get the trailing edge of that waveform, that's when we're told to shut the injector off. So if the injector wasn't shutting off, that would affect the actual trailing edge of that waveform. So again, I can go ahead and turn that pattern back on to a live pattern, and it's going to pretty much be locked in because of the way how I got my trigger and time base and everything set up. But just for your new scope users in here, if you happen to be using the Autel scope that came with your scanner, a quick, easy way to get this set up is I hit the little car at the top of the screen. I pull up actuators because the fuel injector is an actuator. I select injector, and then from the right-hand part of the screen, I have a couple choices. So I'm using a multi-port point fuel injection type of injector. I'm looking at the injector voltage. I also have a selection for injector voltage and current, which would require the two channels to be hooked up at the same time. So that's how I actually acquired that signal. But I wanted to show you that because technically if I were to start accelerating the car or whatever, that on time should obviously change in relation, because the faster the RPM is going, the more fuel delivery the car is actually requesting and requiring at that time. Also, that's a great way to determine if I have an electrical integrity problem with the fuel injector itself. That integrity problem could be a bad injector, could be a circuit problem, always remember that. Could even be a PCM problem. So I incorporated a little bit more hands-on into this educational video. Again, I'm just scratching the surface on all of these. I could go on and on about any one of these subjects. I'm just scratching the surface. If you guys didn't mind the longer length duration of a video in the future for the other educational videos, I'll incorporate more hands-on into those types of classes that we go through as well. So again, go ahead and remember to like and subscribe to this channel. Definitely comment. I read every one of the comments. I try to respond to every comment. Let me know if you guys think I'm doing a good job. If you guys want me to see any type of changes on my part, let me know. I'm here to try to help you guys.